So now we're going to use Prometheus. So why am I showing two systems? Why can't I just like pick one? And, the two systems are extremely different. The big thing, like the first thing that you notice is that Snap has a push approach. So you have the Snap thing running everywhere and you publish to your data metrics thing. And Prometheus is the other way around. Prometheus sits somewhere and it goes grab data from everywhere. There are lots and lots and lots of different approaches between the two projects. And I think at this point it's probably almost a religious issue. And so I think it's interesting to show both. So the Prometheus server is the thing that will go and grab the metrics. It will store them in its own internal time series database. And it has also like a simple graph engine. So it's a kind of all-in-one thing. You can, of course, you can query the metrics differently, but it's a little bit like the same component is embedding the daemon and InfluxDB and Grafana. Then the configuration, how do we set it up? We give it a configuration file, and in this configuration file, we list a number of endpoints to scrape. So to explain what I mean by that, something that exposes metrics to be consumed by Prometheus expose something traditionally on /metrics. And for instance, if I check those demo links, this is what is called the node exporter. So it's metrics for a node, so for a machine basically. So if node disk reads merge for device VDA, so that's like disk statistics. I probably have something about memory somewhere in like tons and tons and tons of metrics, like node memory, huge pages, blah blah blah, node netstat, etc., etc., etc. So this means that it's super easy to expose your metrics to Prometheus. You just have to write an HTTP server that writes like line-oriented data like this, and that's it. If you're already thinking, wow, that must probably be horrendous from a performance perspective, it can also support protobuf, which is a binary protocol and doesn't require parsing or anything, and is super, super crazy efficient. So in the config file, we will list a bunch of URLs like that. The thing is that we can be a little bit smarter than listing nodes, because if we had to list nodes, we would have to say, okay, so I want you to connect to node 1, node 2, node 3, node 4, node 5. Instead, we can give a DNS name, and it will expand that DNS name and use that, like use DNS as a service discovery mechanism. And where is my config file? There. This is my Prometheus configuration file. And this is all of it. So I'm telling it, okay, I want you to scrape the metrics every second. Then I want to have multiple jobs. So each job is like one type of collector. So first I'm going to monitor Prometheus itself, because Prometheus itself exposes metrics about what's going on inside. So I'm telling it, scrape yourself on localhost 1990. Then I'm going to have a node job, so that's to have like metrics for each VM. And here I use DNS SD config, that's DNS service discovery config, and I'm telling it I want you to resolve the name tasks.node. Remember when we did the overlay network thing? I show you, look, if you resolve tasks.rng, it gives you all the IP addresses for the RNG containers. So here, when we will resolve task.node, it will give us all the IP addresses for the node containers. Type A and ports, that's to indicate the DNS extra options, because you can also use survey records. And then I create another job, which is cAdvisor. And so node is the one to get the VM metrics, and cAdvisor is the one to get the container metrics. And that's my Prometheus config file, and then I don't need to update it anymore, and it will automatically pick up new nodes. Right, so first thing, we will create a network for Prometheus. So that's the easy step. I'm going to make sure that I'm back to node 1. Yep, that's good. Docker network create -- driver overlay prom. Okay. Then I'm going to run those node and cAdvisor services. In theory, the node exporter should run directly on the hosts. But in practice, if you know enough container foo, you can run it in a container and still get access to all your metrics. This command line seems absolutely awful, but it's a different kind of awful from the one where we use the SSH trick, basically. If we break that down, we're saying, okay, I want to create a service called node, like node exporter, global, so it will run everywhere. It will be in the Prometheus network, and I'm going to bind mount a bunch of host file systems to the container. Specifically, I'm going to expose /proc and /sys because they contain all the information that the node exporter is using. Like when the node exporter shows all this information, it's basically reading stuff from /proc and /sys. And I'm also binding so I'm binding proc and sys so that I can get access to generic metrics, and I'm binding / so that I can get access to file system metrics, like basically DF. Then I say I want to run prom node exporter, and I just give a few extra options. Like if I'm running the exporter straight on the machine, I just run node exporter and that's it. But here it's in a container, so I'm just telling it, by the way, I don't want you to get the metrics from /proc and /sys, but from /host/proc and /host/sys. And there is a typo here, it should be /host/sys. And I also tell it to ignore the file systems that belong to the container here. So I'm still going to copy paste that, and it's okay if we don't fix the typo. The only drawback is that some metrics are not going to be reported correctly, but for this example, it doesn't matter. All right. So now I have a node exporter running on each of my hosts. Then we are going to use cAdvisor. cAdvisor is a project that started at Google and that exposes metrics for containers. So it's a kind of bridge, if you want, between all the low-level C groups and etc., and exposing that with a clean API. And among other things, it supports scraping by Prometheus. So same thing, I create cAdvisor in global mode so that it runs everywhere, and I also bind mount a bunch of directories that cAdvisor needs, and that's it. If you wonder, how did you guess which things you needed to map? I just went to the cAdvisor webpage, and they give an example using Docker run, and I just translated the format of the Docker run parameters for the Docker service parameters, and that's it. And same thing for the node exporter. I think there was a blog post written by Julius Volz, one of the founders of Prometheus, explaining like how to get Prometheus running on your DigitalOcean server in containers. And same thing, there was an example with Docker run, so I just translated to Docker service create, and that's it. So I'm going to paste that here. Okay, so that's my config file, as I said earlier. We need to pass that config file to the Prometheus server. So here I have to create a custom image, but I feel a little bit silly when doing it because I'm creating a custom image just to drop one tiny little file in the image. So it feels a little bit weird, but that's okay, we're going to do it anyway. And that's the Docker file to build the image. I'm saying use Prometheus version 1.4.1, drop my custom config file instead of the default config, and that's it. Okay, so if we go to the prom directory in the repo, we have like this Docker file and this Prometheus YAML file. So I can do docker build -t localhost 5000 /prom dot. So this is pulling the Prometheus image, adding the config file, and we're done. Then I push that to my registry. So docker push localhost 5000 / prom. Done. And now I can do docker service create with that Prometheus image. Docker service create -- network prom -- name prom -- publish. So Prometheus is on port 9090, so I'm going to expose it on 9090 as well. And my image name is localhost 5000 / prom. Okay, let's wait until it's up and running. Curl localhost 9090. Good. I go to my web browser and I point it to port 9090. Any of my nodes again. So that's the Prometheus default interface.